The Isle of Eigg is an island in the Inner Hebrides off the west coast of Scotland. Temperatures here rarely rise above 16 degrees Celsius, even in the summer. The frequent rain falls on grassland, shrubland, and moorland. Despite the raw climate, the islanders get their electricity from solar cells.
They really help us to save burning diesel. It's over the course of their lives, it's cheaper to run than using diesel, and they really help us during the summer. They really make up the difference for us during the summer. It's a fantastic energy source for us.
Until just a few years ago, diesel generators provided the Isle of Eigg with its electricity needs. But the falling cost of solar cell production is having an impact around the world. Solar power is now cheaper than electricity produced by generators, even in foggy Scotland. All in all, renewable sources cover nearly 90% of the Isle of Eigg's electricity needs. The problem is, a variety of energy sources has to deliver precisely the amount of electricity needed by the island's inhabitants at all times. Striking a balance with the ever-changing weather conditions on the island poses a real challenge. 12 power inverters located in a control room prevent any power failures.
Oh, in a way, these are almost the key to the system because they set the initial frequency and voltage to which the system operates.
The technology comes from Germany and was developed especially for island systems. The power inverters manage the interplay of various renewable energy sources and maintain a constant voltage and frequency in the island's power network. Along with solar and wind, another energy source contributes to the island's power supply. Most of the rain falls onto a high plateau. Part of the rainwater that flows into the valley is captured by pipes. The resulting hydropower drives a turbine, which then drives a generator. 3 hydroelectric power stations like these provide some 60% of the island's electricity needs. When the streams run dry in the summer, increased solar power takes over. Along with daily fluctuations, seasonal variations also affect the island's power supply. The intelligent power inverters are equipped with software that manages these long-term changes as well. The software ensures that 5 kilowatts of power capacity are always available to each inhabitant. The consistent use of renewables is a major advantage to the islanders.
We were burning a barrel of diesel a month, which was costing us roughly £150 a month for 5 hours electricity a day. Now we have 24 hours electricity for about £35 a month.
More power for less money. To further develop the system, residents collect measurement data on location. The data helps the German developers of the power inverters further optimize island systems as part of a special research program. After all, these are not the world's only islands. Emerging countries in South America and Africa contain remote regions that are unlikely to ever be connected to a power network. The nearest pylons are located hundreds or even thousands of kilometers away. Villagers here used to rely on diesel generators, just like the islanders in Scotland once did. Research carried out in Germany ensures that in the future, the intelligent power inverters evaluate data from local weather reports as well. If, for example, clouds block the sun in a remote Bolivian village, the power inverters can pre-calculate how long the decrease in power production from the solar cells will last. In addition, they analyze the power needs of consumers. Thanks to this data, the power inverters further optimize the interplay of solar park, batteries, and generators. The goal is to run the generators only when absolutely necessary, and only in the optimal speed range. That saves even more fuel and leads to further cost cuts. The market for systems like these is enormous. Every year, island systems around the world require a total capacity of 20 gigawatts, the equivalent capacity of 20 nuclear power plants. Researchers in Germany are not just developing solar systems for islands. A special program set up by the German government has earmarked some 50 million euros to fund research activity in Germany's solar power industry. Scientists in the town of Freiberg are using this funding to develop the next generation of solar cells. At a special test station, the scientists are constructing a module using innovative PERC technology. Here they can test the new modules independently of weather conditions. Inside the so-called steady-state sun simulator, researchers are comparing the new PERC cells with a module using conventional technology. 6 500-watt light bulbs provide the necessary energy. The bulbs emit wavelengths of light across the solar spectrum. At this high level of radiation, scientists in the testing station have to wear special protective clothing. A measuring device shows if the simulator's radiation is evenly distributed. The innovative PERC cells contain special layers of material. Inside the cell, rays of light hit electrons embedded in the silicon lattice. Energy from the light free the electrons from the lattice. The upper part of the cell contains an electric field which draws electrons toward the top. The solar cells produce electricity by transforming visible light into electric energy. Infrared light releases the electrons from the lattice in the lower part of the cells. But these electrons don't reach the upper electric field, preventing them from producing a current flow outside the cell. The new PERC technology provides a layer on the bottom of the cell that reflects the electrons, allowing them to reach the upper electric field as well. The new layer also reflects the infrared light. This allows the reflected radiation to free additional electrons from the lattice, and that increases the flow of electricity. The test results are clear. Compared to conventional cells, the PERC modules produce around 10% more electricity. That means this technology can further lower the costs of solar power. PERC technology is the next step toward highly efficient solar cells. We've taken the first step, put the product into mass production, and will further develop the product here in Freiberg. The scientists are working on a further optimization to allow solar modules to use even more light. Until now, solar cells have only used light shining from above. The underside of PERC cells, however, possesses different optical properties due to their special construction, and that allows the light reflected from the bottom to be used as well. Engineers install these so-called bifacial modules onto a bright surface. Depending on the background, further measurements show the indirect radiation improves the new module's performance by up to 25%. And that further lowers the cost of solar power. Even without the use of indirect radiation, the innovative PERC technology improves the effectiveness of cells in other ways. PERC technology is a brilliant platform for further optimization. We're currently at 21.7%. Now that we've made a detailed analysis, we could increase that to 24%. That means a module with 260 watts today could get up to 370 watts. Germany is the first country to mass produce these innovative solar cells. Global demand is expected to double over the next 5 years. PERC technology improves the module's performance without requiring major changes to the production process. Further research is securing jobs in Germany's solar power industry. In addition, the innovative cells and island systems are making solar power more competitive around the world. And not just in the rough climate of Scotland.